Let's get started here with 5-2, and you should be on page 126, the degree of a polynomial. Okay, I'm going to review yesterday's lesson. So if you were lost or kind of struggling, let's go ahead and review it, and you're going to help me out. Okay, this first one, 11x, is it a monomial or not? Yes. How many of you say yes, it's a monomial? Okay, Andrew, why is this a monomial?
It's a product between a number and a variable.
Good. Okay, a monomial can be one of three things, and this is your definition from yesterday. Ready? It's deep. It could be a number, or a variable, or a product of numbers and variables. Okay? So is this a number only? No. Is it a variable only? No. But what is it? A product of numbers and variables, or a number and a variable. Okay, good. This second one right here, is that a monomial? 2a squared b to the fifth. Is that a monomial?
Yes.
Drew, why is this a monomial?
Because it's a number and a variable multiplied together.
Yep, and it's several variables and one number, they'll all be multiplied. Okay, this third one up here, is this a monomial? Negative x y to the fourth.
Yeah.
All right, who says it's a monomial? Sophie, why is that a monomial?
Because there's variables.
Okay, the variables. But it's a negative variable.
The exponent can't be.
Oh, very nice. Listen to me, guys. In a monomial, you can have negative numbers or negative variables, but what can you not have? Negative exponents. So we don't have that. We're good. By the way, where's the number? Is there actually a number?
It doesn't have to be a number. It's right in front of you.
It's a 1 right here. There's a 1 right there. So there is a negative 1. Can you have a negative number in a monomial? Of course you can. You do right here. All right, this last one, and technically was written like this. Is that a monomial? Okay, who says it's a monomial? Darius, why is this a monomial?
Because there's a negative exponent.
Okay, you give me why, like a negative answer. Give me why it is. Like what positively makes this a monomial. It's either a number or a variable or a product of numbers and variables. There you go. All of these are products of numbers and variables. Okay, good. What makes something not a monomial? If you have negative exponents, division or adding and subtracting. Okay, good. So these don't have that. That's why they're monomials. All right, we're going to talk about the degree of a polynomial, but first we're going to start off with the degree of a monomial. Okay, I got to start back up with the monomials. And these are all monomials? Good. Okay, let's look at the first one here. And I'm going to give you the degree, and I'm going to see if you guys can pick up a pattern of how I figure out the degree. The degree of this monomial is based off its variables and their exponents. What's the exponent of x? 1. Yes, there is a 1 there. So the degree of this monomial, so the degree is 1. It has a degree of 1. So that first one has a degree of 1. All right, so you're just writing this down. If you don't understand it, I don't expect it. Let's see if you can pick up a pattern. The second monomial, okay, we're talking about monomials to start off with, has a degree. And the way I figure out that degree is I look at the variables and I look at their exponents. So what are the exponents here of the variables? 2 and 5. Okay? You know what I do with those two numbers? I simply add them. It's degree of 7. That's it. Degree of 7. Now, when I write the degree of 1 and the degree of 7, I'm not changing anything in the monomial. I'm just describing it. It's like, how do you classify it? Well, you call it a degree of 7 right here. Okay, let's look at it here with this third one, top right. It also has a degree. But I'm a little confused because it has two variables, but I only see one exponent. Does the x have an exponent?
Yeah.
What is it?
1.
1. What's this exponent plus that exponent? So what's the degree of the monomial? 5. Degree of 5. How many of you are starting to see a pattern? Okay? Find the degree of the last monomial. Just try it out. If you get it wrong, thankfully you're using pencils to erase that. And if you don't have a pencil, you can scratch that out. The degree of the last monomial is blank. Don't say it out loud. Okay. How many of you have an answer? You have something? Okay. Brad, what's the degree of this monomial?
5. Or, no, 10.
How'd you get 10?
Just added them all together.
Added what all together?
4, 3, 2, and 1.
Yeah, and what are these numbers called right here? The exponents. And we get a degree of 10. How many of you got a degree of 10? All right, that's how you find the degree of a monomial. Is that pretty straightforward? Okay, remember, I'm going to give this out as a mental note again. Did I change anything of the monomial? Did I actually write out like 5w to the 10th, x to the 10th, y to the 10th, z to the 10th? Did I change anything like that? No, I'm just describing it. Okay? I'm just describing. Let's move on. Now we're going to talk about not monomials, but
Polynomials. Trinomials. Quadranomials. Stop!
all right, let's see if you guys can remember what kind of expression is the top one. So who can tell me? Is it a monomial? No, it's not a monomial, but it is a binomial, which is also known as a polynomial. So we're good on that. And then the second expression is not a monomial. It's not a binomial, but it is a trinomial, which is also known as another type of polynomial. Okay, so all of these are polynomials, specifically bi and tri. All right. In the binomial, how many terms do you have? 2. 1, 2. Okay, I'm now trying to find the degree of this binomial and then later the degree of this trinomial. So first, let's look at the first term. What's the degree of this first term?
2.
It's a degree of 2. I just write that to help myself out as a degree of 2. What's the degree of the second term? Oh yeah, there's a 1 here, so it's a degree of 1. Does anyone know what the degree of this binomial is? I want your guesses here. And a lot of them are going to be with thought. Some are going to be random, but some may even get the right answer. Anyone?
3. 2.
Okay, nice. We got 1, 2, and 3. Okay, the answer is 2. Degree of 2. Good question. Like, how did I get that, right? Okay, do you guys see how I got each term's degree? Sorry, just each term's degree? I just got 2 and I got 1. The way I get the degree of the whole binomial is I take the highest degree. Degree of 2. Yep. Even easier than adding or subtracting. You just pick the one that's the highest. Okay. How many terms are down here in this trinomial? 1, 2, 3. What's the degree of this term? 4. I got the 2 plus the 2 is 4. What's the degree of the second term? 2, because there's a 1 and a 1 right there. What's the degree of the last term? 4, because the exponent is only 4. What's the degree of the whole trinomial? Degree of 4. That's the highest one, so you keep it. Degree of 4. You guys okay with that? We're building up to something here. We're not just like, okay, great, you know the degree, awesome. Fun fact, have you guys ever had those popsicle sticks after you're done with that ice cream, and then there's like a fun fact? The Mars is blah, blah, blah miles from Jupiter. Yay! Doesn't this seem kind of like a fun fact right now? It's kind of like, whatever. Okay, if it seems that way, I understand, but we're building up to something. Any questions, though, on how to get the degree of a binomial or trinomial? Any questions? Okay, good, because I think you guys are getting it. Let's look at these two, and then I'm going to give you some on your own. All right, this top polynomial is what type of polynomial? Binomial. That's a review from yesterday. Okay, it has 2 terms, and it's 19 and negative 3x. Let's find the degree of this binomial. What's the degree of 19, the first term?
0. 1 half.
Let's look at 19, by the way. 19 is a special number. Do you guys remember when we're finding the degree of a term, don't we have to look at the variable and then its exponent? How many variables does that have?
1 0 1 0. Oh, wait,
Okay.
1.
Let's look at it right here. Written down on this board, is there any variable written down? No. But there is a variable. In fact, there are many variables, and they will tell us what the degree of this term is, okay? I'm going to pick a random variable. I'm going to pick x. Throw it up there. But x to the 0 power. X to the 0 power. You're like, huh? I mean, why do you, what? Does anyone remember what x to the 0 power always equals?
1.
Not 0, 1. Okay, time out. If Mr. A just threw up x to the 0, doesn't that change what it already was? Well, what's 19 times 1?
19.
So did I change the value when I threw up that x to the 0? No, x to the 0th, as some of you like saying, is just a big fat 1. But you're like, Mr. A, you're talking blah, 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 0th power. Why does that matter? Guys, what is the degree of this term?
19. 1. 0.
0. It has an exponent of 0. So what's the degree of this number? 0. Mm-hmm. Now, you're like, how am I going to remember that, Mr. A? Here's how you can do it very easily. If you just have a number all by itself, 19, negative 17, 23, the degree of that term is always 0. Just remember it as 0. That's all you have to do. All right, what's the degree of this term? 1. What's the degree of this binomial?
3.
Degree of 1. It's the degree of 1. That's the highest degree. You name a polynomial, you give the degree of a polynomial by its highest term degree. All right, the second one right here. What is it? What kind of polynomial? Good, binomial. Boom, boom. What's the degree of the first term? 1. There's a 1 right there. What's the degree of the second term?
3.
Do you notice, guys, there's a difference between this and this? Because some of you said 1 and or 0, and you're like, why is this 0 and that's 1? This has a variable, and it's 1. This has, good, and no variable, so you give it a 0. All right, what's the degree of this binomial? Degree of 3. Very good. You guys okay with that? It's time for me to quiz you a little bit on it. Okay, on page 127. Page 127. Where it says try these, I want you guys to do numbers 2 through 4. Just give me the degree of that polynomial. Just give me the degree on 2 through 4.
So 2, 3, and 4?
Yep, 2, 3, and 4. I want you to get the degree of the polynomial on page 127, where it says try these at the bottom. Give me the degree of number 2, of number 3, and number 4. I'll help you out with number 2 if you're still kind of lost. Okay, how many terms does that polynomial have on number 2? How many terms? 1, 2, 3, 4. What's the degree of the first term? 5. What's the degree of the second term? 7. The third? And last. All right, what's the highest degree? So what's the degree of this polynomial? Degree of 7. Now, some people ask, Mr. A, do we have to keep writing degree of 7? Like, can we just write 7? In the homework, you will just put the number. I'm just emphasizing this 7 isn't me actually combining things and changing things. It's just talking about the degree of 7. That's it. All right, number 3. Who's still working on it? Anybody? Okay, finish it up. And then work on number 4 after you're done with that. So I'm going to ask several of you different questions on numbers 3 and 4 to make sure you guys are getting it. Jack, number 3, how many terms? 3 terms. All right, ready? The first term is what degree?
3.
The second term?
2.
Third term?
7.
Okay, what's the highest term?
7.
So what's the degree of the trinomial?
7.
7. That's it. Number 3 is a 7. Okay, number 4, Sam. How many terms does number 4 have? 4. Okay, the first term, what degree is it?
9.
Second term?
11.
Third term?
0.
Nice. A number by itself has a degree of 0. And then last term?
2.
Yep, good. You can say second or 2. What's the highest degree?
11.
What's the degree of the whole thing?
11.
There you go. That's it. Guys, get this stuff? Good, because we just got done with the easy part. Oh, finally is a good way of putting it. All right. I need you to copy this chart down because you need to memorize it. It's the chart on page 126, that purple chart with the purple heading, I mean. We're not going to do the whole thing. I'm just giving you 2 columns. So you're going to have a degree column and a name column. I know I'm using a lot of different terms, but but I need you to know what each term means because it's going to ask you what's the name, what's the degree, and what's the type. So are those all the same thing? No. Okay, ready? If you have a degree of 0, and does anyone remember what terms have degrees of 0? Just numbers. Just numbers. Like if it's 19 or negative 100, that has a degree of 0. And it has a special name if that's the highest degree. It's called a constant. That's a special name, constant. So you know what you call 19? It's just called a constant. You know why you call it a constant? Yeah, what does it mean to be a constant? It does not... Okay, it does not have a variable. It doesn't change. It stays the same. That's 19. Okay, that's if you have the highest degree of 0. If you have the highest degree of 1. Highest degree of 1. So you look at this polynomial and the highest term is just a 1. You call that linear. You know why we call that linear? What word is in there? Maybe a mathematical word that's in there that you probably are familiar with? There's a line. When we graph these, we're going to get some kind of line. We're going to get some kind of line. That's what we call it linear. Okay, you're like, cool, another popsicle fun fact. That'll make a lot more, that'll affect you a lot more, not chapter 5, but chapter 6. And then 7 and 8 and 9. And then 12. Okay. If your highest degree is 2, then you have a special name called quadratic. It's weird. Quad. What does that remind you of?
4.
Oops. Wait. Is that typo? Talking about 2 is... Okay. Oh, yes. This is why. When you have a degree of 1, you get a line. But how in the world did we get a degree of 2 giving me quadratic? Okay, think of it like this. Think of a square. Okay? How do you find the area of a square? You do its length times width, right? Length times width. Or don't we know a square having the same length and same width? Don't they have to have the same one? So you do length times width. How many things are you multiplying there? Square or quad gives me 2 things to multiply. You're like, not sure I get that. Let's look at it with 3. What's the special name for a 3, highest degree of 3? Cubic. Cubic? What are you talking about? Cubic? Wait, what does that sound a lot like in geometry? A cube. If you have a cube, how do you find the volume of a cube? You multiply the length times the width times the height. How many things are you multiplying?
3.
That's how we got cubic. That's how we got quadratic. And that's how we got linear. Okay, so the names, they're not just random. And no, it wasn't a typo. It's there for a reason. Okay, you guys okay with that? Because I'm going to start asking you about it. Some of you seem to be doing all right. Some of you are like, are you going to make it through this class? Like physically make it through the class? I don't know. Okay. Yes, ma'am.
So, what if your degree was higher? Are there more names?
I think there are more names. We just don't deal with them enough. So for you guys, these are going to be it. Someone asked me in another class, and I didn't look it up, but we don't use them as often as obviously these right here. We use these a ton. And that's not only this year, but years to come. Okay, let's get into our next polynomial. All right, look at this polynomial right here. Write it down, please. Oh. Oh, there you go. Yep. I'm going to talk a couple things about this and reviewing a lot of concepts so you're not totally in the dark when you have to do this on your own. Okay, I got 4x cubed minus 2x squared plus, wait, do you hear those words? 4x cubed, 2x squared. Same words? Square, quadratic, cubed, cubic. Okay, but anyway, we have how many terms up here? 4 terms. Okay, good. What's the degree of the first term? 3. Second term?
2.
Third term?
1.
Last term?
0.
Good, 0. All right. Do you guys know anything about the degrees?
3, 2, 1, 2.
Yeah, so what order is that when you go 3, 2, 1, 0? Yeah, decreasing or descending order. Have you guys heard of descending order? We've done that before here. Okay, when you write a polynomial in descending order of the degrees, you call that standard form. And you will have to know that. Of course you will have to know it. Why am I wasting your time to tell you all about it? Standard form. You write it in descending order of the degrees. And we have 3, 2, 1, 0. Who should I pick? Who should I choose? Hi, Hudson. You sure? All right, he asked for it. Hudson, this polynomial has 4 terms. What is the special name of this polynomial? 4 terms. Excuse me?
It doesn't have 4 terms.
Oh, sorry. 1, 2, 3, 4 terms. What's the special name for it?
Doesn't have one, but you can add terms.
Okay, sometimes you can add like terms. If there are any like terms, are there any up here? Oh. Now, Hudson, I asked you if you wanted this question, and your first answer was correct. What was it? Cubic. That's the name, cubic. I don't care how many terms. What's the highest degree? 3. Cubic. That's it. Does that make sense, guys? Okay, 3 things I'm going to ask. Wow, 3 things I'm going to ask you. What is the type? Monomial, binomial, trinomial. What is the degree? That can be from 0 all the way to 11 so far. And then what is the name? Constant, linear, quadratic, and cubic. That's what you're looking for. All right? So what's its name?
Oh, wait.
You're going to say it.
Cubic.
Cubic. All right, good. Yes, sir. Question?
Well, we have to give like 3 answers.
Some will be at most 2, and they'll be like numbers 3 and 2. Like that's where you write. Maybe I'll throw in some of those other ones.
Will there ever be a problem that's constant?
Mm-hmm. Yeah, if I gave you 19, and I said, all right, how can you name this polynomial?
But then it would be
What's the highest degree? 0. Constant. And basically any number just by itself is just a constant because it doesn't change. All right, something else here. So this is standard form. this above here is standard form. But what if I wrote it like this? So this right here is in standard form. And then I wrote it like this. It's not in descending order of the variable. It's in ascending order of the variable, or ascending order of the degree. This is not standard form, but you should be able to write it like that. If I said write it in ascending order of the variable, this is what I'm talking about. If I said standard form, that is what I'm talking about. And this is the main one. Mr. Ray, why do I care about this? Because sometimes you get a problem that's written like this, and you have to do what? Rewrite it into standard form. Can you do it? Let's see here. Guys, you notice what's the sign of 4x squared? 4x cubed? What's the sign? Positive. What's the sign right here?
Positive.
Okay. What's the sign of 2x squared?
Negative.
What's the sign of 2x squared here?
Negative.
What's the sign of 6x?
Positive.
What's the sign of 6x?
Positive.
What's the sign of 3? What's the sign of 3? Is this a different value than that? No, but it is rewritten in a different form. You need to be able to do that. And you need to be able to do that right now. Rewrite this polynomial in standard form. Polygon, I was tutoring geometry students with polygons, so I got those polys mixed up. Polynomial in standard form, that means in descending order of the variable. Descending order of the variable. Okay. Some of you are still working, but I'll get the first parts here. If I'm writing it in standard form, which term should come first, Josiah? 4x to the 7th. Why does that come first? Because it has the highest degree. So 7 comes first. Matthew, what comes next? How do I write it? Do I just write x to the 5th, or do I write... Good, plus x. Wait, how do you know it's plus?
Because it's positive.
It was positive there, so it's plus there. Okay. Lana, what's the next term that comes up?
Negative 2x.
Squared, negative 2x squared. And then lastly, the plus x. Is that written in descending order of the variable?
Yes.
Mm-hmm. So is that standard form?
Yes.
That's standard form. There is a practical reason why we do this. When you're working out problems later on this chapter, you're going to get your answer that looks like this. You worked it out and you got that. But then it says write it in standard form. So what do you have to do? Rearrange it to look like that. So here's your answer. Standard form. Okay? Wait, that's not what I wanted. But that's fine. I'll take it. Don't forget, guys, just a little reminder. When you can add like terms, do it. Goodbye, Swivel.